recording. Okay. And there's some more terminology I just want to present with functions. Let me just make sure I recorded. Okay, good. Okay. But when you get the output from an input value, so when you get an output from an input value, that's what we call evaluating a function. That's evaluating a function. You know, so if going back to that first example with the months and days, you know, if you plug January in and got 31, that's evaluating a function. Basically, if you're given the input and you want to find the output. Now, what can also happen is you might be given the output or know the output somehow, but you want to find the input. In that case, you're doing this. You're solving an equation involving a function. So let me say it again. In this case, you basically somehow know the output and you want to obtain the corresponding inputs. That's what's happening here. So it's just terminology the book uses. I figured it wouldn't hurt to use it here as well. But now let's do an example. So here what we're going to do is we're making a function g, and what I'm going to do is I'm going to define that function g, but I'm going to use a table. So again, here what I'm saying is I'm using an input. I'm saying how to get, from each input, I'm saying how to get each output, corresponding output. Okay, so that's what this is saying. All right, so for example, what would g of 3 be? Well, let's find 3. That's our input, x. Let's find 3. Oh, right here. So what does g of 3 do? Go to the y value, which is 9. So again, our input, which is x, that's 3. Our output then is going to be 9. So g of 3 is 9. All right, that's one example. Oh boy, excuse me. G of 1, okay. Let's find that. What would that be? Well, it's just like with 3, but now we're doing the same thing with 1. We find 1 in our inputs. G of that, right? Go to y, you're going to get 8. When x is 1, right? G of 1 is y, which is 8. I mean, what the table is telling you is from each x value, how you get the corresponding y value. That's what the table is actually doing for us. That's really what you want to do when you have a function, when you define it. How to get for each x value, how you get the y value. Well, now let's go the other way. So here what we're going to do is we're going to use the same g, but what we're going to do now is we're going to go the other way. That is, we're going to assume we have our output and we want to find the input. So let's say we want to find all x such that g of x is 8. So again, we're solving an equation involving a function. Okay, well, so find all x such that g of x is 8. Well, in our y row, we have 8 over here, and that gives us 1. So we know 1 is an x value. We also have 8 over here, right? So because of that, 4. So we have 8 over here, and we see that that corresponds to 4 as our x. So g of 4 is also 8. So what x values give us a y value of 8? Well, when x is 1, we get 8. When x is 4, we get 8. When x is 1, we get 8. X is 4, we get 8. So 1 and 4 are the only solutions. Okay, what about this one? What about 3? Well, excuse me, well, when x is, let's see, when x is up, here's when y is 3. When x is 2, we can see g of that is 3. What about over here? No, not there, excuse me. What about here? When x is 5, g of that is 3. So it looks like it's just 2 and 3. 2 and 5, excuse me. Notice that when x, here we're saying x is 3. We're not saying g of x equals 3. Here, x is 3. And let me also say this, even though we have different inputs give the same output, that's okay. There's nothing wrong with that in a function. Each input has to give only one output. That has to happen. And that's what's happening here. So when x is 1, we get only one output, 8. When x is 2, we only get one output, 3, and so on. You know, if for some reason, instead of 2 here, if we had 3 and something else, then we wouldn't have a function. So here's another one. We want all x, so that g of x is 1. But notice that 1 is never a y value. See? 1 is never a y value. So what does that tell us? That tells us this has no solutions. There's no x, so that this is equal to 1. In other words, there's no input whose output is 1. There's no x value whose corresponding y value is 1. So there are no solutions to that equation. Okay, now that's how we can define a function using a table. But as I said before, there's different ways of defining a function. So we have a table. In the first example, we used words. We wrote out in words and sentences what the function does. We can use a formula. And that's what we can do here. So with a formula, what's going to happen is you could probably guess that there's going to be some algebraic expression, an algebra involved, that is, which will specify how to get our outputs from our inputs. In other words, you're going to have some kind of algebraic expression involving x that will tell us how to obtain the output from each x value. So for each x value, right, we want to know how to get the output, the y value, or the f of x value. So this is one example. With this example, right, here we're algebraically saying take your input x, multiply it by 8, and add 9. So if we wanted to get, let's say, f of 2, right, f of 2, well, this means we replace x by 2. That's what we're doing, right? We're going to take that 2, multiply it by 8, and add 9. So 2 times 8, that's 16. Add 9, we get 25. So f of 2 is 25. So when the input is 2, our output is 25. Over here, same idea, except now x is negative 1. And in this case, we get 1. Negative 1 times 8 plus 9. We get negative 8 plus 9, which is 1. So when negative 1 goes into the function as input, out comes 1 as our output. So we're evaluating a function then. That's good. But now notice in the next part, we want to find all x so that f of x is 2. We want all x so that f of x is 2. So in this case, we're solving an equation involving a function. I think that's yep, that's it. Okay, so how would you solve this one? Well, actually, I kind of write it here. F of x is equal to 8x plus 9. So we have this equation we form, right? 8x plus 9 is f of x. So we have 8x plus 9 equals 2. Now we want to solve this equation for x. And that takes some basic algebra. Solving equations, as we see here. You subtract 9 from each side, right? That's the first thing, because you want to get x all alone. We get 8x equals negative 7. From here, right, all I did was I moved the 8x closer to the equal sign, but we want x, right? We don't want 8x, so we divide by 8. And we get x then is minus 7 over 8. So this is our x. So this is saying that when x is, so from here we get that f of negative 7 over 8 is equal to 2. That's what this is saying. I mean, you probably could have checked it by evaluating it, but I didn't do that. Okay, hold on, let me just see something. Okay, hold on.